Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to our third episode, Impurities Guidelines. First of all, we have to define impurity. Impurity is any component of the new drug product that is not the drug substance or an excipient in the drug product. Impurities are classified into three categories: organic impurities, inorganic impurities, and residual solvents. Organic impurities arise during the manufacturing process and or storage of the new drug substance. They can be identified or unidentified, volatile or non-volatile, and they include starting material, byproducts, intermediates, degradation products, reagents, ligands, and catalysts. Inorganic impurities result from the manufacturing process. They are normally known and identified and include reagents, ligands, and catalysts, heavy metals or other residual metals, inorganic salts, and other materials like filter aids and charcoal. Listing of impurities and specifications. The specification of a new drug substance should include a list of impurities. Can be used to predict those impurities likely to occur in the commercial product. The selection of impurities in the new drug substance specifications should be based on the impurities found in batches manufactured by the proposed commercial process. The new drug substance specifications should include the following list of impurities: organic impurities, each specified unidentified impurity, any unspecified impurity with an acceptance of not more than the identified threshold. Total impurities. 2. Inorganic impurities. 3. Residual solvent. Residual solvents are defined as organic volatile chemicals that are used or produced in the manufacture of drug substance or excipients, or in the preparation of drug products. Moving on to classification of residual solvent. Residual solvents are classified into three classes. Class 1 solvents are the solvents that should be avoided because they are non-human carcinogenic or strongly suspected human carcinogenics, or they are environmental hazards. Class 2 solvents are the solvents that may be used but should be limited in use because they are non-genotoxic animal carcinogenic or possible causative agents of other irreversible toxicities such as neurotoxicity or teratogenicity, or they are solvents that are suspected of other significant but reversible toxicities. Class 3 solvents are the solvents that used in the manufacture with confidence because they are solvents with low toxic potential to man and there are no health-based exposure limit to them. There are solvents with no adequate toxicological data was found. The following solvents in Table 4 may also be of interest to manufacturers of excipients, drug substances, or drug products. However, there are no adequate toxicological data on which to base a PDE was found. Manufacturers should supply justification for residual levels of these solvents in pharmaceutical products. There are options of describing limits of Class 2 solvents, which could be used but have to be in limited amounts. There are options to describe the limits of Class 2. But first, we have to define this term, which is permitted daily exposure, or PDE, is the maximum acceptable intake per day of residual solvents in pharmaceutical products. There are two options available when setting limits for Class 2 solvents. Option 1 is considered for doses that do not exceed 10 grams per day. The concentration limit in ppm stated in Table 2 can be used. This limit was calculated using equation 1 below by assuming a product mass of 10 grams administered daily. Concentration equals 1000 times PTE divided by dose. Here, the PTE is given in terms of milligram per day and the dose is given in gram per day. If all excipients and drug substances in a formulation meet the limits given in option 1, then these components may be used in any preparation, and there are no further calculations necessary provided the daily dose does not exceed 10 grams. Products that are administered in a dose greater than 10 grams per day should be considered under Option 2. Option 2 is not considered necessary for each component of the drug product to comply with the limits given in Option 1. The PDE in terms of milligram per day, as stated in Table 2, can be used with the known maximum daily dose and equation 1 above to determine the concentration of residual solvent allowed in the drug product. Such limits are considered acceptable provided that it has been demonstrated that the residual solvent has been reduced to the practical minimum. The limits should be realistic in relation to analytical precision, manufacturing capability, and reasonable variation in the manufacturing process, and the limits should reflect contemporary manufacturing standards. Option 2 may be applied by adding the amounts of residual solvents present in each of the component of the drug product. The sum of the amounts of solvent per day should be less than that given by the PDE. Moving on to reporting levels of residual solvent. The following statements are given as acceptable example of the information that could be provided by a supplier of excipients of drug substances to a pharmaceutical manufacturer. The supplier might choose one of the following as appropriate. Only class 3 solvents are likely to be present. Loss on drying is less than 0.5%. Only class 2 solvents X, Y are likely to be present. All are below the Option 1 limit. Here, the supplier would name the class 2 solvents presented by X, Y. Only class 2 solvents X, Y, and class 3 solvents are likely to be present. Residual class 2 solvents are below the Option 1 limit, and residual class 3 solvents are below 0.5%. If class 1 solvents are likely to be present, they should be identified and quantified. Likely to be present refers to the solvent used in the final manufacturing step and to solvents that are used in earlier manufacturing steps and not removed consistently by a validated process. If solvents of class 2 or class 3 are present at greater than their Option 1 limits or 0.5% respectively, they should be identified and quantified. And until here, wrapping up our third episode, until we see you again in the next episode.